Hi, hello everyone. Welcome to my channel. This is 𝐕𝐵, and in this video, I'll explain you how to create a VPC, subnet, internet gateway, NAT gateway, route table, and EC2 instance on AWS. So here, firstly, Amazon VPC is a virtual private cloud, and it is a service which is offered by Amazon Web Services. And Amazon VPC provides a logically isolated area where we can create virtual resources. By creating Amazon VPC with some of the CADR range, we can create subnets, internet gateways, NAT gateways, route tables, and everything. So think of it like a virtual data center in the cloud where you can launch resources like virtual machines, databases, and applications, just like you would use in a physical data center. But instead of being tied to a specific location, your virtual data center is in the cloud and you can access it from anywhere at any time. With Amazon VPC, you can get complete control over your virtual networks, including the ability to create a virtual private networks VPN to connect to your on-premises infrastructure, and you can configure subnets, route tables, and network gateways, and you can launch resources like EC2 instance, RDS databases, and Elastic Beanstalk applications. And you can use security groups and network access controllers to control access to your resources. So at last, Amazon VPC is a powerful tool that helps you to build, scale, secure, high availability applications in AWS cloud. So here you can see this is the structure right now we are going to create. First, we are going to create a VPC with some of the CADR range. And after that, we are going to create two different subnets. One is public subnet and one is private subnet. And after that, we are going to create internet gateway. And using this internet gateway, we are going to provide internet to this VPC. And after that, we are going to create two different types of route tables. One is private route table and one is public route table. And we are going to associate our subnets to this route table. And after that, we are going to create NAT gateway. And using this NAT gateway, we are going to provide internet to private EC2 instance. And at last, we are going to create two different EC2 instance. One is public EC2 instance and one is private EC2 instance. And we are going to access public EC2 instance using internet gateway. And we are going to access private EC2 instance using NAT gateway. So let's start doing all this in a practical. So first we need to log into AWS Management Console. So here you can see this is my AWS Management Console. And we need to navigate to VPC. Directly search for VPC, Virtual Private Cloud. So here you need to directly select VPC. And here you can see you need to select your VPCs or else directly you can select your VPCs. So here you can see right now I was having only the default VPC. So this is the default VPC which is provided by Amazon. So when I select here subnets, here you can see these are all the default subnets. So when I select route table, here you can see this is the default route table. So here you can see this is the default route table. So when I select here internet gateway, this is the default internet gateway. So here you can see this is the default internet gateway. And here when I select NAT gateways, we don't have any of the NAT gateway. Here you can see no NAT gateways found. So let's create all these custom. So let's close this all. So first we need to create a VPC. Directly select here create VPC. And here we need to give the VPC name. So here I'm going to provide like custom VPC. And here we need to use the IPv4 CADR range. So here you can see this is the IPv4 CADR range. So highest is netmask 16. So here 16 comes with 65,536 IPs. So in this video, let's go with /21. Here /21 comes with 2048 of IPs. So directly come here, and here I'm going to provide VPC CADR like 10.0.0.0/21. So here /21 comes with 2048 of IPs. So here you can see 2048 of IPs it will come. So let's directly come here, and here you can see this is the tag. So this is optional, you can give or else you may not give, that is up to your wish. So here I'm going to select directly create VPC. So here you can see VPC has been created. So when I select here your VPCs, so here it will display all the VPCs. So here you can see this is the custom VPC right now we created. So when I select this, it is in the available state. So here you can see netmask we created with /21. So here /21 comes with 2048 of IPs. So now we need to create a subnet. So directly open here subnet. And these are all the default subnets. So let's create a custom subnet in our VPC. Directly select here create subnet. So before creating this subnet, I will tell you what is a subnet. And here subnet is nothing but subnet contains a group of IP addresses, guys. So think a subnet is like a small room in a larger house. Just like how a room has its own unique address, a subnet has its own unique IP address. So here, when we create any of the subnets, here we are having two different types of subnets. One is public subnet and one is private subnet. So using public subnet, we have route to internet gateway and we can access from the internet. From using private subnets, we don't have route to the internet gateway and we are accessible from the internet. So that means we don't have accessible from the internet using private subnets. So you need to remember that. So directly select your VPC IDs. So it was asking like under which VPC you need to create this subnet. So I want to create under custom VPC. So directly select your custom VPC. And here you can see associated VPC CIDR. So previously we have given for VPC/21. It comes with 2048 of IPs. So now let's create two different types of subnets. One is public subnet and one is private subnet. So when we create any of the subnet, we need to give the name of the subnet. So here I'm going to provide name like public subnet. So this is the name I am giving. So here we need to give availability zone. So that is up to your wish, guys. If you directly select here no preference, by default AWS will take any of this availability zone. So here I'm going to select US East 1A. And here you can see this is the IPv4 VPC CIDR range. So we have given /21. So here we need to give the subnet range. So here I'm going to give 10.0.0.0/24. So here 24 comes with 256 of IPs. So here you can see 24 comes with 256 IPs. So here you can see 256 IPs. So when I select here, you can see here 23 comes with 512 of IPs. So when I come here and when I select here 23, here you can see 512 IPs. So we don't need that many of IPs. So let's go with 256 IPs. So here you can see I'm going to select 2/24 netmask. So it comes with 256 IPs. So here tags. So here also tags is optional. You can give or that is up to your wish. Let's create another subnet. So here you need to select add new subnet. So right now we created only the public subnet. So now let's create a new private subnet. Directly select any of the names. So here name I am giving private subnet. And here availability zone. This is up to your wish. If you select no preference, by default AWS will take any of this availability zone. So here I'm going to select US East 1B. And here this is the IPv4 VPC CIDR range. So here we have given /21. So here we need to give the subnet IP CIDR block. So here I'm giving 10.0.1.0/24. Here /24 netmask comes with 256 IPs. So here you can see 256 IPs. So here why I am giving one means. So here you can see previously we have used this subnet range. So that's why here I'm using one. So if I select here 0 and when I select here create subnet, it will not create, guys. Here you can see CIDR address overlaps with existing subnet. So here you can see it was saying like overlaps with existing subnet. So this is the here you can see 10.0.0.0. Same we have given for subnet 1. So here you can see for same this is the same we have given for subnet 1. So that's why it was not accepting. So let's change here 10.0.1.0. So now it will accept. Directly select here create subnet. So here you can see subnet was creating. So here you can see two different subnets has been created. So let's close this and let's reload this. And here you can see public subnet 1 and public subnet 2. So when I open this public subnet and let's come here. So here you can see state it is in available. IPv4 CIDR range for subnet we have given /24. So here /24 comes with 256 IPs. So but here you can see available IP addresses it was showing only 5. Why? Because means AWS will reserve 5 IPs for any of the future issues. So that's why it was showing only 51 IPs. 5 IPs will be reserved by AWS. So here you can see this is the availability zone. Under this availability zone, we created this subnet. And here you can see under this VPC, we created this subnet. Under custom VPC, we created this public subnet. So let's select private subnet. So this is the private subnet. And let's come here. Here you can see IPv4 CIDR. So here also we have given netmask /24. 10.0.1.0/24. Here also it comes with 256 IPs. So here you can see, but it was showing available IPv4 address is 251. So here also you can observe like 5 IPs will be allocated by AWS for any of the further issues. So here you can see VPC. For this custom VPC, we attached this private subnet. You need to remember this. So now we need to create internet gateway. So directly select here internet gateways. and this is the default internet gateway. So let's create custom internet gateway for our custom VPC. So directly select here create internet gateway, and here we need to give the name tag. So that means here we need to provide the internet gateway name. So here I'm giving custom internet gateway. So this is the name I am giving. So here tags is optional, that is up to your wish. You can give or else you may not give, that is up to your wish. So here I'm going with the default one. Key I'm going with the name, and value same name. Here I'm providing custom internet gateway, or else you can change, guys, that is up to your wish. Directly select here create internet gateway. So now internet gateway will be created. So here you can see we created internet gateway, but state it is in detached mode. So that means we didn't associate this internet gateway to any of the VPC. So to associate this internet gateway to any of the VPC, here you can follow two different steps. Here directly you can select here attach to a VPC, and directly you can select here your custom VPC. So or else directly select here internet gateway. So this is the internet gateway. Right now it is in detached mode. That means this internet gateway is not using any of the VPC. So now let's connect this custom internet gateway to our custom VPC. Directly select your actions, and here you need to select attach to VPC, and here you need to drop down this, and here you can see custom VPC. So using this internet gateway, we are going to provide internet to this custom VPC, guys. You need to remember that, and directly select this, and directly select here attach internet gateway. So here you can see state has been changed to attached. So using this internet gateway, we are going to provide internet to this custom VPC. So up to now, here you can see, up to now we created VPC and we created two different subnets. One is public subnet and one is private subnet. And after that, we created internet gateway, and using this internet gateway, we are going to provide internet to this VPC. So now we need to create two different route tables. One is public route table and one is private route table. And we need to associate our subnets to this route table, guys. So directly go to this console and directly select here route tables, and here you can see these are all the default route tables. So now let's create a custom route table. Directly select here create route table, and here we need to specify the name of the route table. So here I'm going to give public route table. This is the name I'm giving. So here it was asking like under which VPC you are going to create this route table. So I want to create under my custom VPC. Directly select here custom VPC, and these are the tags. Tag I'm going with name, and here this is the name it was taking public route table. So here you can change or else you may not change, that is up to your wish. Directly select here create route table. So before doing this route table, I will explain what is the purpose of route table. So here the main purpose of route table, it is used to route traffic between subnets in a VPC. So here by using route tables, it is like a map that shows how to route traffic between instances, guys. So you need to remember that. Directly select this. So here you can see we created a public route table. So directly select this route table. So what we are going to do is now we need previously we created public subnet and private subnet. So here you can see in subnets, here you can see we created public subnet and private subnet. So we need to associate this public subnet to this public route table. So directly select here subnet associations, and here you need to select edit subnet association, and here you need to select your public subnet, and here you need to select your save association. So that means we have associated our public subnet to this public route table. So route table will distribute traffic to this subnets. So here you can see under details, here you can see explicit subnet associations. We have associated our public subnet. So now let's select here routes, and here you need to provide your internet gateway. Directly select here edit routes and add route, and here you need to select 0.0.0.0.0/0, and here we need to provide internet gateway. And using this internet gateway, we are going to provide internet to this subnet, to this public subnet, guys. You need to remember that. Under if you create EC2 instance under this public subnet, it was having internet. You need to remember that. Directly come here and select this custom internet gateway, and directly select here save changes. Here directly select route tables, and here you can see we created a public route table. Under subnet associations, we are associated our public subnet, and in routes we have given this internet gateway. So now let's create private route table for this private subnet. So directly come to route tables, and here directly select create route table, and here we need to give the name of the route table, and here I am giving private route table, and here you need to give the VPC. So under which VPC you are going to create this route table? So I want to create under custom VPC. So these are the tags. Here tags are the optional, guys, and here key I'm going with the name, and value I'm going with the default one, private route table. So here also you can change or you may not change, that is up to your wish. Directly select here create route table. So here you can see route table has been created. So let's directly select here route tables. So here you can see this is the private route table. So we need to associate our private subnet to this private route table. So directly select here subnet associations, and here you need to select edit subnet association. Directly select here your private subnet, and directly select here save. And we have associated in details, you can see we have associated our private subnet to our private route table. So now here in routes you need to create NAT gateway. So here you can see NAT gateways. So here you need to create a NAT gateway, and using this NAT gateway you need to associate to your private route tables. So before doing this, let's create two different EC2 instances, like public EC2 instance and private EC2 instances, and let's do a lab. Then you can understand how then you can understand how internet gateway and NAT gateway works. So let's directly go to EC2 console. So here you can see this is EC2, and directly select here instances. And right now we don't have any of the EC2 instances, no instances. So let's create two different EC2 instances. Directly select here launch instance. So first we need to specify the name of the instance. So here I'm giving name like public instance. So this is the name I'm giving. So OS I'm going to select Ubuntu, and I'm going with this. Okay. Instance type I'm going with T2 micro, and key pair. Here we need to provide our key pair. So right now I don't have any of the keys. So let's create a new key pair. Directly select here create a new key pair, and here I'm giving the name like demo key, or else here let's give yes custom key for EC2. Let's give like this, guys, and here I'm going to select with the dot pem, and directly select here create key pair. So here key pair is nothing but it is the login credentials for our EC2 instance. So here you can see OS I'm going with Ubuntu, and come down, and we created a key pair, and in networking settings directly here drop down this, and you need to select here custom VPC. So here you can see previously we created a custom VPC. So under VPCs here you can see we created a custom VPC. Under this custom VPC we are going to create this EC2 instance. Directly here you can see it was showing only the two different subnets. One is public subnet and one is private subnet. So here under public subnet let's create this EC2 instance. So here you can see RTOS public IP. So here when you are going to create public EC2 instance, here RTOS public IP it always should be enabled. So if you are keeping this in a disable state, public IPv4 address will not be allocated to this EC2 instance. You need to remember that. So here always it should be in enable. By default it will be always in the disable. To avoid this issue, directly go to subnets, and here you need to select public subnet. So under public subnet we are going to create, here you can see this is the public subnet, and here directly select actions, and here you need to select edit subnet settings, and here you need to select enable auto-assign public IPv4 address, and come down, and here you need to select save. So let's come here and let's reload this. So here you can see enabled auto-assign public IPv4 address. So that means now when we are going to create under this public subnet, it will not show disable. It will automatically in enable state. Let's directly come here, and here let's give again public subnet. Come down here Ubuntu I'm going to select, and instance type T2 micro. So here previously I created a key pair. So here you can see custom key for here I have given key. Okay. Let's directly select here under networking settings, directly select here edit, and here I'm going to select custom VPC. So under this VPC we are going to create this EC2 instance. So here I'm going to select public subnet. So here when I select public subnet, automatically it will be in the enable state. So here you can see, so when I select here private subnet, here you can see it was showing disable. Why? Because means here you can see when I select a public subnet, why it was showing enable means, so here you can see I enabled this. So while you need to open this, and here you need to select edit subnet settings, and here you need to check mark this, and you need to save this. So when you are doing this, automatically it will be in enable state. We need to remember this. And after completing this, here we need to create security groups. So here security groups give security to our instance level. So here let's close, remove this, and here let's give custom. So this is the name I'm giving, custom security group for EC2. So let's copy this. Sorry. So this is the name I'm giving. So we need to copy this, and in description, let's remove this and let's paste it here. So here you can see in inbound security rules, by default when we create any of the EC2 instance, SSH will be default, guys. So I'm going with this, or else let's create another security group. Directly drop down this, and here I'm going to select HTTP, and here I'm going to select this CDR block, okay, and anywhere, okay, yes. And after completing this, here you can see under configure storage, I'm going with 8 GB, and directly select your launch instance. Directly select your instances, and let's reload this. And here you can see our public subnet. Sorry, here I'm given name like public subnet. So here let's change this to public instance. Sorry for this, guys. So this is the public instance. So let's create a private instance. So directly select your launch instance, and here you need to give name like private instance, and come down, and here we need to select OS. Here also I'm going with Ubuntu, and here we need to select instance type, and here I'm going with the previous key, which is custom key for key. And here under networking settings, here we need to select our custom VPC, and here we need to select previously using public subnet we created our public EC2 instance, and now let's create private subnet. Using this private subnet we are going to create this EC2 instance. So here when you are going to create under private subnet, here all automatically it should be in disable state, guys. So here always it should be in disable state. So directly come down, and here let's select existing security group. So this is the security group previously I created. So here you can see custom security group for EC2. So I'm going to select this, and configure storage I'm going with 8 GB, and directly select here launch instance. Let's reload this, and here you can see public instance I have created under public subnet, and private instance I have created under private subnet. So now let's do one thing. Let's connect to this public instance. Directly copy public IPv4 address, and here I'm using MoboXTM session SSH, and here we need to paste our public IPv4 address and remove this, and here you need to provide Ubuntu. Select this, and here you need to give the path of the key pair. So here you can see this is the key previously I have given, and select OK. Now it will connect to this private EC2 instance. So here you can see it was connected to this private EC2 instance. So here you can observe, guys, here it was coming internet. So here you can see when I select here sudo apt update -y. So here you can see internet is coming. Let's wait. So let's clear the screen, and let's give here ping www.google.com. So here you can see request is going and it was coming back. So here you can understand like internet is coming to this EC2 instance. So here you can see this is the, let's stop this. So here you can see this is the public instance, guys. Here you can see IP 10.0.0.190. So let's directly come here, and public instance here you can see 10.0.0.190. So here you can see same IP address. So this is the public EC2 instance. So for this here you can see under route tables. So here you can see for this public route table we associated our, here you can see, let's select here details. So here you can see we associated our public subnet. For this route table using internet gateway. So here you can see IGW. Using this internet gateway, it was providing internet to this instance, public EC2 instance. So now let's do one thing. Let's connect to our NAT gateway. Sorry, let's connect to our private EC2 instance. Directly open this, come here, and here you can see this is the private EC2 instance. Directly select this private EC2 instance. So here you can see it is in running state. So let's reload this. And here you can see for private EC2 instance, here you can see we don't have public IPv4 address. So when I select here public instance, here you can see this is the public IPv4 address. So when I select here private instance, here it was not showing public IPv4 address. Why? Because means we haven't associated our IPv4 assign auto IP address to this public EC2 instance. That's why it was not showing this public IPv4 address. So using this private IPv4 address, we need to connect to our virtual machine. So we need to connect to this private instance. So now I will tell you how to connect to that instance. So now using this public instance, we need to connect to this private instance. So directly come here, and here first we need to upload this key pair. So here you can see this private instance key we need to upload to MoboXTEM. So directly come down here, you can see for this private instance we have given key pair like custom key for key. So same key we have given for public instance and private instance. So let's directly come here. First we need to upload that key to here. Directly select this, and you need to select here custom key for key. So this is the key. Open this, and here you can see it was uploading to our terminal. So here you can see it was uploaded. So when I select here ls, so here you can see this is the key. So when I select here ll, so here you can see this is the key. For this key, it was having read write permissions, and read permissions. So here we need to provide only read permissions, guys. That means 400 permission. So let's come here, and here you can see private instance. Directly select here connect. So it will guide you how to connect to that instance. So here you can see you need to give read permissions to this key. So directly copy this and come here and paste it here and enter. So again when I select LL, and here you can see permissions has been changed to only read. So now using this key we are going to connect to this private instance. So let's go back. So here you can see using this key, private key, we are going to connect to this private EC2 instance. So let's come here. Now I will show you. Let's clear the screen, or else let's perform this command ssh-i, and here we need to provide this key, and here custom key for key.pem. So here you need to provide ubuntu at the rate, and here you need to give the private EC2 instance private IP address, guys. Here you can see this is the private EC2 instance. You need to copy this private IPv4 address. Directly copy this, come here, paste it here, select enter. So here you can see here you need to select yes. So here you can see it was connected to our private EC2 instance. So this is how you need to connect your private EC2 instance, guys. So here you can see IP 10.0.1.88. So here you can see 10.0.1.88. So this is the private EC2 instance. Using this public instance, we connected to this private instance. So this is the steps you need to follow. So here when I select sudo yum update, sorry, this is the Ubuntu. So here you need to use sudo apt update -y. Here it will not update, guys. Here you can see connecting to US East 1, it was showing this error. So why? Because means for this private EC2 instance it doesn't having internet, so we need to provide internet. So now I will explain you how to give internet to this private EC2 instance. So here we have to use one concept, which is NAT gateway. So here you can see directly open this, and here you can find that here you can see under VPCs, here you can see NAT gateway. So here you need to create a NAT gateway, and using this NAT gateway you need to provide internet to this private EC2 instance. So it will throw an error, guys. Here you can see it will surely throw an error. It will stop. Here you can see failed. It was saying failed. This is the private instance 10.0.1.88. Here you can see 10.0.1.88. So this is the private instance. So let's come to VPC and let's select here directly NAT gateway. So here you can see right now we don't have any of the NAT gateways. So here you need to select here create NAT gateway. So using this NAT gateway, we are going to provide internet to our private EC2 instance. So after creating this NAT gateway, you need to associate this NAT gateway to your private route table. So using that route table, it will provide internet to this private EC2 instance. So here I'm going to give the name like custom. This is the NAT gateway. I'm giving here custom NAT gateway. This is the name I'm giving. So here you can give whatever you want, guys. That is up to your wish. So here you need to select subnet. So here you need to select subnet which was having internet. So here I'm going to select public subnet. So for this public subnet, it was having internet. Using this public subnet, it will take internet. This NAT gateway will take internet using this public subnet, guys. So under subnet, you need to remember this. Under the subnet, you need to provide any of the public subnet. So here I'm going to select this public subnet, and here connectivity type I'm going to select public. And here when you are going to create NAT gateways, here you need to create elastic IP. So here if you are having any of the existing elastic IP, so you can directly select that existing elastic IP, or else here directly select here allocate elastic IP. So automatically here NAT gateway will create automatically elastic IP, guys. So here you can see you can find here elastic IPs under EC2 console. Come down here you can see elastic IPs. So let's open this. So let's reload this. And here you can see this is the NAT gateway. So previously here we selected allocate NAT gateway. So that's why here you can see elastic IP address. So that's why automatically it was created elastic IP. So here let's come here, or else let's directly select this. So let's come here. Okay. So what I'm telling you guys, after completing this lab, try to remove your NAT gateway and elastic IP. Why I'm telling like here NAT gateway and elastic IP will charge more amount from you. This is not free, this is paid. So that's why you need to remove this NAT gateway and this elastic IP after completing your lab. Directly come down here. You can see we allocated our public subnet here, and we have allocated our elastic IP and this tags. This is optional. Directly select here create NAT gateway. And let's wait, let's close this. So here you can see state it is in pending. So here you need to see add to, select NAT gateways, and let's reload this. So here you can see this is the NAT gateway we created. So here you can see state it is in the pending state. So here you need to see add to state. So it takes nearly 1 to 2 minutes to come to add to state. So meanwhile let's go to route tables and let's associate this NAT gateway to our private route table. Directly select your route tables. Let's reload this. And here directly select private route table, and here you need to select routes, and here you need to select edit routes and add routes, and you need to select this, and here you need to select NAT gateway, guys. So here why I'm selecting NAT gateway means, so using this NAT gateway we are going to provide internet to our private EC2 instance and private subnets. So here directly select NAT gateway, and this is the NAT gateway, custom NAT gateway, and directly select here save. So now by using this, so here you can see this is the private route table. So in this private route table, we associated our NAT gateway. So using this NAT gateway, it will provide internet to our private EC2 instance. So here you can see this. This is the private EC2 instance. For this instance, it will provide internet. So let's select here NAT gateways. So again, I'm telling you, after completing your lab, you need to remove your NAT gateway and elastic IP. You need to remember that. Directly close this. And here you can see still it is in pending state. So here you need to see add to state. So when you see here add to state, automatically for your private TC2 instance, it will provide internet. So here you can see 10.0.1.88. So for private instance 10.0.1.88. So this is our private instance. So let's wait. Let's come here and let's reload this. And here you can see it is in available state. So that means it was working fine. So let's come here And here you can see previously when I select here sudo apt update, it was failed, guys. So here you can see. So here you can see when I select here previously sudo apt update, it got failed because of internet issue. So when I select here sudo apt update -y, it will work. So here you can see it was working. So here you can understand how NAT gateway will provide internet to our private EC2 instance. So this is our private EC2 instance, guys. From public EC2 instance, we connected to our private EC2 instance. So this is the same process you need to follow. So here you can see, let's clear the screen. So here when I select ping www.google.com. So here you can see request is going and it was coming back. So why? Because means using this NAT gateway. So here you can see using this NAT gateway, it was giving internet to this private TC2 instance. So here you can see 10.0.1.88. Here you can see 10.0.1.88. Using NAT gateway, it was giving internet. So let's close this. And here let's install any of the package like apt install Apache 2 -y. So here I'm going to install Apache 2. It was saying permission denied. So let's try with the super user sudo apt install Apache 2. So here you can see it was installing. So internet is coming, guys, for our private EC2 instance. So if you want to get back to your public instance, I will explain you that. Wait, guys. After completing this, I will tell you. So here you can see Apache 2 has been installation completed. So let's clear the screen. So here you can see right now we are in our private EC2 instance. So if you want to go to your public EC2 instance, directly select here exit and enter. So here you can see 10.0.0.190. So this is our public EC2 instance. Directly come here and select public instance. So here you can see 10.0.0.190. This is our public instance. So again, if you want to connect to your private instance, directly perform same command. Here you can see ssh-i. So here this is the key of our private EC2 instance. So here you can see when I select this private instance, so here you can see that key. So here you can see this is the key, custom key for key. So here you can see this is the key, and after that you need to give your OS name Ubuntu at the rate of, and here you need to provide private EC2 instance private IP. So here you can see this is the private EC2 instance. You need to provide your private IPv4 address. So this is how you need to connect. So directly select here enter. So before performing this, here you need to give read access permissions. So if you want that commands, directly select here connect, and here you can see here using chmod you need to give read access to this key, and after that you can connect same like this. So here you can see this is our private EC2 instance. So 10.0.1.88. So here you can see, let's select here instances and private instance 10.0.1.88. Here you can see 10.0.1.88 ping www.google.com. So here you can see request is going and it was coming back to our private EC2 instance using NAT gateway. So now you can see, let's do one thing. Let's go to NAT gateways, and in route tables, let's remove this NAT gateway. Then automatically connection will disconnect, guys. So let's directly go here and directly select this route tables, and this is the private route table. Directly select here routes and here edit routes, and here you can see again I'm showing you. Here you can see, when let's clear the screen again. Let's stop this and let's clear the screen, and again ping www.google.com. So here you can see request is going and it was coming back. So let's come here and let's remove this NAT gateway. So here you can see this is the NAT gateway. So when I remove this and when I select here save associations, so here you can see updated. So let's directly come here. So here you can see request has been stopped, guys. So here you can see it was not, request is not going and it was not coming back. So this is how you can understand how NAT gateway works. So again, let's go here and let's select this route tables, and let's go to these routes and let's select here edit routes, and here let's select our route table, our NAT gateway. For this private route table, let's select this NAT gateway, and here select this NAT gateway and save association. So here you can see updated route table. So here you can see again request is going and it was coming back. So again when you remove this, it will stop automatically. Edit routes remove, save association, and here you can see updated route. So here you can see request is not going in, it was not coming back for our private EC2 instance. So this is how route table works. So yes guys, that's it for today's video, and this is how you can connect to your route private EC2 instance using route table. And in previous video I explained you how to create VPC, subnet, internet gateway, route table, and EC2 instance. And this video I explained how to create route tables and associate with your private EC2 instance. So let's close this, and here you can see right now we are in our private EC2 instance. So here you can see 10.0.1.88, 10.0.1.88. So if you want to go to your public instance, select here exit and enter. And here you can see this is our public EC2 instance 10.0.0.190. So here directly select public instance. So here you can see 10.0.0.190. Here you can see 10.0.0.190. So when I select here ping www.google.com. So for this EC2 instance, it will it will be available internet guys. Why? Because means using internet gateway, where we have given internet to our public subnet. So here you can see. Let's select here route tables. So here you can see route tables. So let's directly select here public route table, and here you can see for this public subnet using this internet gateway. So here you can say 𝐸GW. So using this internet gateway, we given internet to this public subnet. To this public subnet using internet gateway we have given internet, so that's why request is going in, it was coming back. Same like this, request is going in, it was coming back. So yes, that's it for today's video. Now I will explain you how to remove your custom VPC, subnet, internet gateway, NAT gateway, and your elastic IPs and everything. So after completing this lab, you need to remove your, here you can see, you need to remove your NAT gateway guys. Here NAT gateway is not free, this is paid guys, you need to remember that. So you need to remove this. So before removing this, you need to terminate this EC2 instances. Why? Because means we created these two EC2 instances under our public subnet and private subnet. So here you can see under public subnet and private subnet we created these two EC2 instances. So if first you need to terminate this, after that only you can delete all these custom VPC, subnet, route table, internet gateways, and everything. So here when I select VPCs, and when I select here custom VPC, and when I select this, and when I select here delete, so here you can see unable to delete, it was showing this VPC cannot be deleted until you complete the following actions. So here you can see it was showing some of the issues. Why? Because means we created this two EC2 instance, and these two EC2 instance are in running state. So first we need to terminate this instance. Directly select this two EC2 instance, and here directly select instance state, and directly select terminate instance and terminate. So let's wait, and after terminated this, we can directly remove our VPC and everything. Let's directly select this. Let's refresh this. Let's come here. So here you can see this is the elastic IP address. So this is paid guys. You need to remove this also. So I will explain you each and everything how to remove that. So it is in shutting down state. So let's wait. We need to see here terminate. So let's wait. So here you can see our private instance is terminated. So when I come here, here you can see connection has been lost. So that means we are going to terminate this EC2 instance. So here you can see two EC2 instance has been terminated. So let's directly go to VPCs, and let's reload this, and directly select this custom VPC actions, and directly select here delete VPC. Okay, it was not showing this. Let's do one thing. Let's close this, and let's close this, and let's open this VPC again. Select here VPCs, reload this, select custom VPC actions, and directly select here delete. It was showing unable to delete. Here you can see it was showing NAT gateway. So okay, let's do one thing. Let's go to route tables, private route table, and route table. Okay, first let's delete NAT gateway. Directly select this NAT gateway actions, and here directly select delete NAT gateway, and here you need to select delete. and directly delete this. And here NAT gateway is not free, it is paid, guys. So here you can see it is in deleting state. So it takes nearly 1 to 2 minutes again to delete this NAT gateway. So meanwhile, let's delete our elastic IP. So directly come down and here you need to select elastic IPs. So here directly select this elastic IP actions, and here you need to select here release elastic IP. Cannot be released elastic IP. So let's wait. So let's wait. It is in deleting state. So meanwhile, let's try this VPC. Let's reload this and directly select this custom VPC action. Okay, it was not showing this. So when you are working with cloud, you need to be patient, guys. So let's wait. Actions release. Okay, it was not showing. So let's see here NAT gateways. So here you can see it was showing deleted. So let's directly come to VPCs. Select this VPC, delete. Okay, it was showing VPC contains one or more. And let's again try this, guys, and directly select this custom VPC actions and directly select here delete VPC. So here you can see now it was showing to delete. So directly select this and here directly select delete. So when you delete this VPC, so here you can see when you delete this custom VPC, automatically custom internet gateway will be deleted, public route table will be deleted, and private route table will be deleted, and public subnet will be deleted, and everything will be deleted. Directly select this delete. So here you can see everything was deleted. So we don't have custom VPC. Here you can see this is the default VPC. Let's reload this. We don't have our subnets. And let's reload this. And here you can see we don't have our custom route tables and internet gateway. We don't have our custom internet gateway and everything. So let's select here NAT gateways. So here you can see it was deleted. So let's come to here and let's select this elastic IP. Select this actions, release elastic IP, select here release. Now elastic IP will be deleted. So here you can see elastic IP address released. So that means we deleted our elastic IP. So, and this is the process we have done. And yes guys, that's it for today's video. And if you like my video, please do like, share and subscribe to my YouTube channel, guys, and see you in the next video, and bye.